Our Sun is 4.6 billion years old and is constantly bombarding the Earth with high-speed ions. Between May 10th and May 12th of 1999, NASA's ACE and WIND spacecraft found that these solar winds had lost 98% of their density. This is a comparison between the aurora activity in the northern hemisphere on May 11th and a more typical day. The Earth's magnetosphere expanded up to 5 times its size that day due to the lack of interaction with solar winds. But first, let's ask ourselves, what is the Earth's magnetosphere?
Electric currents are generated by both Earth's rotation and convection, or the circulation of molten rock in the Earth's interior. The mantle consists of iron, nickel, and cobalt, which are electrically conductive materials. The motion of these charged particles is what creates a magnetic field. The magnetosphere is what protects us from plasma ejected by the sun. Because solar winds are made of ionized particles, they are attracted by the Earth's magnetic poles. The faster the ions move, the more energy they contain. This energy is then released into the atmosphere, creating the phenomenon of the aurorae.
Last month, a dissertation was presented by a student at Princeton University detailing the properties of, to put it plainly, water. Now, we're all 60% water, and we all inhabit a rock whose surface is 71% water. So what could we possibly not know about water? Well, we do know that water can exist in many different forms, and at extremely high temperatures and pressures, water dissociates and enters the superionic phase. The oxygen anions form a crystal lattice structure, which is in a sea of hydrogen cations. If this sounds familiar, it's because transition metals such as iron, nickel, and cobalt are structured the same way. It is inferred that superionic ice exists on both Uranus and Neptune. This would explain both planets' unusual magnetospheres, which are non-dipolar and non-symmetrical. Uranus and Neptune are similar in size and density, and their ice is likely primarily composed of water, methane, and ammonia, since most icy planetesimals feature hydrogenous compounds involving carbon, oxygen, and nitrogen. However, superionic ice would not be the primary conductive fluid present. That would actually be metallic fluid hydrogen. The Voyager 2 found that the magnetic fields of the planets are generated close towards the planet's surfaces, meaning they are likely to experience interference by multipolar substances when observed by spacecraft. This would explain the complex data recorded, but as of right now, it's anyone's guess, as there is still lots of our universe that we don't know. Thank you for watching this video. All sources are credited in the video description.
My school is insane. My work's down the drain. But she's a total blam blam. She said she had to squeeze the Dutchie, and then she, don't lean on me, man, 'cause you can't afford the ticket. Back from Suffragette City. Don't lean on me, man, 'cause you ain't got time to check it. No, my Suffragette City was out of sight.